Okay, this is Algebra 2, Lesson 22. We're going to talk about uniform motion problems and equal distances and proportions and some more triangles. So basically, we're going to use motion problems to solve for equations that have to do with velocity, speed, average speed, basically it. And we can use subscripts, for example, RW or RW, if you look at the top of page 105 on Lesson 22, or R of R, can all stand for the rate that Ruby walked. And we will always use a diagram to help us find the distance formula. So what is the distance formula? Distance formula is distance equals rate times time. So if we draw a picture and we have two distances, so and this is supposed to say D1 and D2. I know my chicken scratch is still off here. Okay, so we have D1 is equal to D2. They're going the same distance. They start at the same place on this particular one. Here they have the same distance, but they just went in opposite directions. So we say D1 is equal to D2, then we can say the rate times of the first of 1 and time of 1 is equal to the rate of 2 times 2, right? So we said this is the distance formula. All right. But we have to substitute the R1 and T1 for D1, as well as R2, T2 for D2. Saying that, why do we use this? Well, let's look. It says Roger made a trip on Sunday, and Judy made the same trip on Monday. Roger traveled at 12 miles per hour. Judy traveled at 20 miles per hour, so her time was 2 hours less than Roger's. How far did they travel? Well, let's start with what we know. They traveled the same. Yes. So we're going to say distance of R for Roger and distance of J for Judy. So we know this is distance of Roger and distance of Judy. R of R, T of R, and R of J and T of J. All right. They told us Judy traveled at 20 miles per hour, so her rate, so R of J is equal to 20. Roger traveled at 12 miles per hour, so R of R is 12. Yes? And we know that her time, Judy's time, was 2 hours less than Roger's. So time of Judy is equal to time of Roger plus 2. Oh, no, we said her time is less, so it's minus 2, or we could say time of Roger is equal to time of Judy plus 2. Because her time was 2 hours less. She would add 2 hours to her time to get the time of Roger's. So now we know that R of R is times T of R is equal to R of J times T of J, right? Because the two distances are equal. This should be coming back to you from Algebra 1. So let's replace what we know. We know R and R. Yes, it's 12. Do we know T of R? Yes, it is T of J plus 2 equals R of J, which is 20. And we don't know T of J. All right, so here we simply have to distribute. So we have 12 T of J plus 24 equals 20 T of J. So I'm going to subtract 12 T of J and put my T of J's on the same side. They're the same subscripts, so they're the same variables. All right, so we simply get 24 equals 8 T of J. And then I want to what? Divide both sides by 8, and I get T of J equals 3. So the time of Judy was 3 hours. Our question was, how far did they travel? Well, I can simply put this into Judy's distance formula, yes? What was her rate of Judy? We said it was 20. Because we said the distances are the same, so we put 20 for her rate, and her time was 3. So the distance of Judy was 60, and we said that the distances were the same, so they both traveled what? 60 miles. Let's look at example 22. Burr Rabbit hopped off towards the briar patch at 10 kilometers per hour at 10 a.m. At noon, Briar Wolf began the chase from the same starting point. If he caught Briar Rabbit at 2 p.m., how fast did he run? So first we start, it's easier if you draw the diagram. Then you can fill in what you know. All right? So we know that Burr Rabbit, D of R, headed off towards a briar patch at 10 kilometers. So D of R, right, his rate was 10 kilometers at 10 a.m. So he started at 10 a.m. Okay? And then if Burr Wolf began the chase from the same starting point, so he started here, and if he caught him at 2 p.m., so at 2 p.m., they're at the same distance. So this is D of, what's his name? W. Okay? How fast did he run? So what do we know? We know that D of R is equal to D of W. They went the same distance because we said at 2 o'clock. This started at 10. This was at 2 o'clock. And at noon, so he was what? He started at noon, right? So his time is going to be added 2 more hours. So let's write down what we know. So we know R of R is equal to 10. And we know the time of Rabbit was what? Right? We started at 10, and at 2 o'clock they were the same. So from 10 to 2 is 4 hours. So we know his time was 4 hours. Okay? But they're asking us for how the rate of Burr Rabbit. Oh, of Wolf. So what we do know is the time of Wolf, right? He started at noon, and at 2 o'clock is where they're the same distance. His time was 2 hours. So what we do know is we need to find the distance. So we could find D of R by saying his rate, 10 times 4, right? So the distance of Rabbit was 40 miles. Well, they have the same distance. So now for the distance of W is also 40. So we can say that 40 equals, what's his rate? We don't know his rate. We want to find that. So that's R of W. We know his time is 2. So we simply divide both sides by 2. And we get R of W's rate was 20 miles or kilometers per hour. Is that what they're in kilometers? Yes, kilometers per hour. So you simply have to draw a diagram and write what you know and substitute that back in. We'll do more of these problems in class. Attempt your homework on that. Let's move on to similar triangles and proportions. We know the ratios of corresponding sides in similar triangles are proportional. We have been using a constant of proportional, or what we call the scale factor, to find the length of the missing sides. We can also solve for the missing sides by using ratios themselves. So let's consider this triangle on example 22.b. You've got the triangle there. We said if we write the ratio of the opposite sides, corresponding angles, and put the sides from the right-hand triangle on top, we get x to 5 is equal to 9 to 7, and y to 8. They just simply wrote down the proportional, the corresponding sides. So they started with, instead of going from left to right, they went from right to left, which is fine. It doesn't matter as long as you keep the same order for everything that you do. So I'm going to write this real quick. Okay. X, 9, y, 5, 7, 8. That's an X. Okay, and we said these are equal, these are equal. All right? So basically, they said the opposite of this is 9, and its side, this angle is to 7. Then we said this is y to 8. This triangle, large triangle to small triangle. And then x, then these are equal, right? This is our rule. We said if two of the angles are equal, then the third one's equal. So x to 5. Okay, so now we've got 3 different proportions, 3 different ratios. So now if we want to solve for x, we've got 2 here, so we can say 9 over 7 is equal to x over 5. And then we can simply use cross multiplication and then divide both sides by 7. We get x equals 45 over 7. Okay, now we can also do the same thing to find y. We could say, and it doesn't matter, you can put these 2 equal, or these 2 equal, or these 2 equal. As long as you have the same triangle on the top and the same triangle on the bottom. So I've got all the sides of the top on the numerator, all the sides of the right, the one on the right. Then I have all the sides of the left triangle on the denominator. So let's solve for y. We have 9/7 times y over 8. You cross, if you don't know how to cross multiplication, you do 8 times 9 is 72. You cross this way equals 7y. You divide by 7. So y equals 72 over 7. Yes, that's it. Or we could use a scale factor like we did before. We could say these 2 are the same. 5, well, we need to get 2 sides. They're the same. These with 2 numbers. So we can say 7 times the scale factor equals to 9. And you simply divide by 7. Scale factor equals 9 over 7. Then we can simply go 5 times the scale factor equals x. And I get 45 over 7, which I got earlier. So you can either use a scale factor or you can use ratios, and because ratios are proportional, then we can simply cross multiply. So it's just 2 different ways of doing that. Your code for this lesson is to write the word pumpkin on the top of lesson 20. The word pumpkin, in case you didn't hear me, pumpkin, top of lesson number homework 20. Okay? Do your practice problems and we'll see you in class with your questions.